This PowerPoint is an introduction to vectors. Let's suppose you're running back and your coach tells you that you need to run 10 yards to score a touchdown. Sounds easy enough, right? So here you are. You need to get to the end zone, but you ran 20 yards and didn't score. Why was that? Well, we ran 20 yards this way. So what your coach really meant was that he wanted for you to run 10 yards downfield. This means if you didn't run 10 yards downfield in the 20 yards that you ran, you won't get there. So if we break this vector, 20 yards, then we have a downfield part and a lateral part. As a result, you only get 8.1 yards closer to the end zone, which is downfield, and went 18.3 yards laterally. Those lateral and downfield parts of the vector are called components of the vector. So let's talk about how to get components for a vector. Suppose we have a vector that's 18 meters at 55 degrees north of east. 18 meters, 55 degrees north of east. We're going to form right triangles, a right triangle, in order to get this vector to be broken into components. So we have an east component and a north component, and you can see there is a right triangle that's created right here by the components. And notice the components are also perpendicular to each other. So if we were to look at the east component, we would use the trig function of cosine because that is adjacent and we have the hypotenuse. So cosine of 55 is going to be equal to the adjacent divided by 18. Plug cosine of 55 into your calculator and you get 0.5736, and then we multiply both sides by 18 and the adjacent is going to be 10.32 meters, and that will be to the east. Now if we do the opposite side, the north side, then that is going to be sine of 55 degrees, which equals opposite over 18. Punch in your calculator sine of 55 degrees and you get 0.8192, multiply both sides by 18 meters and you get 14.74 meters north. So that's your two components that make up this vector. You got an east component and a north component. This vector is 5.4 meters per second at 30 degrees west of south. Now west of south is over in this quadrant right here. We have west and south. 30 degrees west of south means that we're going to start south and go 30 degrees west of the south direction. So our vector is 5.4 meters per second at 30 degrees west of south. We form our right triangle. Our right triangle right here encloses that 30 degrees, and notice we have a south component and a west component. Now if we wanted to, we could make a right triangle over here with a west component and a south component. The only difference with that is we'd have to figure out this angle, which easy enough is going to be 90 minus 30, which would be a 60-degree angle. So either way, either right triangle that we create, it'll work, but I chose this one because we already have the 30 degrees to enclose. So the south component is going to be cosine. Cosine of 30 degrees is going to be equal to the adjacent because this side is adjacent to the 30-degree angle with the hypotenuse on the other side. And then we're going to punch cosine of 30 degrees into our calculator. We get 8.660, multiply both sides by 5.4, and we see that the south component is going to be 5.68 meters per second south. To find the west component, that's opposite, so we're going to use sine. Sine of 30 degrees is going to be equal to opposite over 5.4. Punch in sine of 30 degrees into your calculator, you get 0.5. Multiply both sides by 5.4 and you get 2.7 meters per second west. So that is the west component of this vector. This last vector is 2.0 kilograms meters per second at 10 degrees north of west. Now we haven't seen these units before, but this is a momentum unit, and we'll get to this in Unit 6. So we have our vector. North of west is over in this quadrant right here. We're going to start west, the west direction, and go 10 degrees north to get to our vector. So there we have 10 degrees north of west. Now we're going to form a right triangle to enclose that 10-degree angle. Now again, we could have formed a right triangle right here, but we chose not to because this angle is already there and we're going to enclose that one. If we chose this one over here, then we'd have to find that angle, which is going to be 80 degrees. So to find the x direction, we're going to use cosine. It's adjacent, so cosine of 10 degrees is going to be equal to adjacent over the hypotenuse, which is 2. Cosine of 10 is going to be 0.9848, multiply both sides by 2, and we get 1.97 kilograms meters per second. And again, that's going to be west because the vector itself was northwest, so we're going to have a west component and a north component. To find the north component, that's opposite, so we got sine of 10 degrees is going to be opposite over 2. Punch in sine of 10 degrees, we get 0.1736, multiply both sides by 2, and we get 0.35 kilograms meters per second north. Now sometimes I don't even try to figure out which side is cosine and which side is sine. When I draw my picture like this, you can see that obviously this side right here is going to be longer, and this side right here is going to be shorter. If you've noticed, in each one of the components, we've always had the hypotenuse, which is the vector itself, times a trig function, whether it's cosine or sine, and components will always either be cosine or sine, of the angle that's in there, that vector right there. So we got the hypotenuse, trig function, angle every single time. So 2 cosine of 10 degrees will be one side, 2 sine of 10 degrees will be the other side. So since I know this one's going to be the long side and this one's going to be the short side, I punch both of those, 2 cosine of 10 degrees and 2 sine of 10 degrees, and whichever one's bigger I'm going to put on the x-axis because I know that has to be the longer one. So that's kind of a way to double check yourself to make sure you got the right components in each one of the sides.